In this example, we're going to look at how to calculate confidence intervals around a mean, right? So we're trying to create a confidence interval for a population mean based on a sample mean that we have. And we're going to do that three ways: with formulas, which are relatively simple, with the TI-83 calculator, and also with StatCrunch. Okay, so just to remind ourselves that all of these things, these confidence intervals, are all the same idea. I put the formulas side by side. So the ones in the boxes are the ones we're using because these are the ones that are dealing with means, right? That's x bar. And then we're using a t here because we don't know the standard deviation of the population, which is the more common one. There's also a version of this formula with a z, because we know the standard deviation of the population we sampled from, and then therefore we can use the z curve, the normal curve. But that is wildly unlikely in the real world. It's more of a learning tool. In the real world, you're not going to know the standard deviation of your population, so you're going to be forced to use the t curve, the t distribution, in this formula instead. So that's why we're going to focus on this one. Now, next to what we're doing is what we did previously with proportions, and you can see that everything is exactly the same. Like I told you guys before, don't get caught up in the details. You're not doing x bar plus or minus e. You're doing some measurement plus and minus your margin of error. And then it's the same. Look, it's the same idea. Everything is the same, only now we have x bar instead of p hat. And then look at how similar these formulas were. For the confidence interval for proportions, you had a critical value that you got off the z table, right, or the z curve. Now you have a critical value that you get off the t table. Same thing. Then you had some sort of standard error that was kind of similar to a standard deviation. Here's the standard error that's very similar to a standard deviation. So they're all related. They're all similar. And if you look for the similarities, it just helps you learn, and you can kind of see how they're all the same. Okay, so just like before, in order to do this, the first thing we have to calculate is E. And the first thing we have to calculate to get E is our critical value. So it's always a good idea to draw yourself a simple little picture to help you make sure that you don't make any simple mistakes. And so, according to the picture, we're trying to do according to the question, we want a 90% confidence interval. So we want to cut off 90% right in the middle in our confidence interval, which means alpha equals 10%, right, or 0.1, 0.10, which means we have 10% left over in the wings, in these what we'll be later calling rejection regions. But that means each piece has half, 5%. And that's why it's t of alpha over 2. So we're looking for t of 5%, alpha over 2. And this would be the same t, right? Just to be a negative number. Okay, so you can look up in the tables and find out what the cutoff is, right? What the critical value is for that much. And the tables are usually pretty good. Remember, you have to worry about your degrees of freedom, because we're now dealing with a t curve that changes based on our sample size, and our degrees of freedom is n minus 1. So in this case, 40 adults use the weight loss program, so our n is 40. Minus 1 is 39, and then you'd have to look it up in a table and hope that the table actually lists 39. Sometimes once you get past about 20, tables normally then start jumping and go to like 25, 30, 35, 40, and stuff like that. So you'd have to use 40 because that's the closest one to it, which means that you're not being perfectly accurate. So it's always better to use technology if you can. Now the TI-83 doesn't allow you to find these critical values. I think some of the more fancier calculators like the Inspire and then the 86 and 89, they might possibly have something similar to that inverse norm function on the T83. They might have something for doing the t-curves, and I'm sure there are things you can find online as well. But if you have access to StatCrunch, you're just going back to our calculators because that's where the distributions are, and we're now dealing with a t distribution. Give it our degrees of freedom, which remember was 39 because our n was 40. we're going to look for the upper tail one, because if we do the lower tail one, it's just going to give us the same number but negative, and we might as well just look for the positive one. And we don't want 50%, we want 5%. Check the picture. Yeah, that looks about right. That looks like about 5%. And then this is our number, 1.64, or sorry, 68, blah, 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 right? So there's our number that we got from StatCrunch. Okay, so we have our t. That's our t of alpha over 2. Remember, because alpha is 10, and so we divide that by 2 because it's half on each side, and it's basically t of 5%. Now we just have to put everything else into the formula, which is a pretty simple formula, not a lot to it. E is going to be 1.68, and I'm going to just round here to 685. Now I would suggest taking as many digits out as you can. I'm just going to do 3 just to save time and space. But remember, the rule is always go 2 digits further than whatever the final answer needs to be. And then S, right, according to our question, their mean weight loss was found to be 2.1, so that's my X bar. I can write that over here if I want to. X bar equals 2.1. Our standard deviation was 4.8, so the standard deviation of our sample was 4.8. Remember, these are both in pounds. You might want to keep track of your units of measure. And then we're doing the 90%, and then it wants to know, was it effective and was it practical? Okay, so plug in everything we know. We're going to be multiplying that by S, 4.8, over the square root of n, which was 40. Slap that all into your calculator and get of 1.27873. That's our E. So now all we have to do is finish it off by doing, p hat, except we're not doing p hats, right? X bar plus and minus E. So we've got our X bar of 2.1, so we're going to do 2.1 plus and minus this 1 point, if you want to round to 1.3 or 1.27, whatever you want to do. But again, very simple computations. Do it in your calculator, do it by hand, and you will get this confidence interval. All right, that means that basically, and we can write it the other way as well, that 0.821 is less than mu, remember, because we're always comparing it to the proportion from our population, is less than 3.379. So that means if everybody did this Atkins diet, we would expect the average weight loss of the entire proportion of adults, because it sounds like they're talking about adults here, would be somewhere between 0.8 pounds and 3.379 pounds over 12 months. So the first question is, does it appear to be effective? Well, yes, it's effective because they lost weight, right? The only way it wouldn't be effective would be if this confidence interval contained 0 or even worse, negative numbers, which would mean they actually gained weight, right? So it is effective, but is it practical? You got to ask yourself, if you went on a diet for 12 months and you lost somewhere between 0.8 and 3.3 pounds, would you be happy? And the answer is probably no, right? You would probably expect to lose more than somewhere between less than 1 and less than 4 pounds in a year. Okay, so that's a great indicator of remembering that something can be statistically significant, which this one is, right? It's effective, but not necessarily practical or worldly, significant type of thing, real world significance. Okay, so that's how we do it by hand, very, very simple. Let's see how we do it with the TI calculator. With our TI, when we want to run stats, right, we go to the stat menu, we go over to tests, because we're going to run various types of tests. The first one's the tests when we're doing actually hypothesis testing. Here we're doing intervals. So, right, there's our Z interval, but that's not what we want. There's a T interval, right? That could be what we want. 2 sample Z, 2 sample T, down to proportions, right? All sorts of different things. So it should hopefully be obvious to you that we want to do a T interval because we're dealing with T's. And then it wants to know, are you going to do it with raw data or with statistics, right? The kind of the summary stuff. And we have summary. We don't have raw data. We have the actual summarizations. So choose enter, and then it changes your inputs here. Now it wants to know, what was your average? 2.1. Hit enter. What was the, right, S sub x, that's the standard deviation of your sample, 4.8. What was your sample size? Well, our sample size was 40. Confidence level, 0.9. and then calculate. And look at that. Same thing we got. It gives you all of the information on the screen, the X bar, the S, and the N. It only does that in case you actually had raw data and you put raw data in one of your lists. Then it would calculate those summary statistics for you as well, because it's often good to know those. Since you already had them, it's just kind of telling you something you already knew. But there's your interval, the same numbers, 0.821, right, and 3.379 if you rounded to 3 decimals. Okay, pretty simple there, right? All right, let's try StatCrunch. StatCrunch is just as easy. You go to Stat, T-stats, right, because we're dealing with T's here, because we're doing confidence intervals around a mean, and we don't know the population standard deviation. If we did know the population standard deviation, we'd be doing Z statistics, but that almost never happens. So we're doing T statistics. We have one sample. We don't have the raw data. We have summary. Then we just have to give it all the information. It was a 2.1. Right? Then we got to give it its standard deviation from the sample, which is 4.8. The sample size was 40. We're not doing a hypothesis test, we're doing a confidence interval. We have to change the level because we want to do a 90%. Compute. And you will see that if I bring this up, same answers again. Right? There's that standard error that we've seen before. Remember, the standard error is the piece of the formula that doesn't include the critical value. So that standard error is just the 4.8 divided by the square root of 40. That's that piece. And then if you multiply that by 1.685, that will give you E. Okay, so 3 ways to do a confidence interval around a population mean. Very simple, straightforward. I would recommend using the formulas a few times if you have the time, and it doesn't take that much time, because it's just a great way to learn. All right, hope this helps.